Question 6 is a rates of reaction question. So we've got the classic question here about Boltzmann curves, where we've got to draw the curves and use the curves to explain how the rate is affected. So we need to explain how increasing the temperature increases the rate of reaction, and we're told we must include a labelled sketch of a Boltzmann distribution. So if you're going to talk about how does increase in temperature increase rate, you are going to need two curves. And when I set this question with my students, quite a few of them only drew one curve. So how can you make a comparison when you've only got one curve? So it's two curves for this one. So the first thing you need to do is make sure your labels are correct for your axes. So it's number of particles on the y-axis and energy on the x-axis. We'll go for the pink curve first. This is the one at lower temperature. Must start in the origin, so it goes up to a maximum and then comes down like this. But remember, you mustn't cross the x-axis. So I sometimes say it's like the plane that never lands, just skims across the bottom, it asymptotes. And then if we draw the higher temperature, again it must start at the origin, but everything's shifted over to the higher energy side. So the maximum here is shifted to the right. It's not as high as the lower temperature, and the end of the curve sort of is higher up as well. And remember, it's running parallel with this x-axis. So we'll have a look at what I've written there. For a reaction to occur, particles must collide with energy greater than or equal to the activation energy. At the higher temperature, so remember that's the yellow curve, the particles have more kinetic energy, and so the area, this area here, after the activation energy, you can see is greater with the yellow curve. So what that's saying is there are more particles with the correct amount of energy, so you're going to get more successful collisions per second. Describe and explain the effect of decreasing the pressure on the rate of the reaction. So decreasing the pressure will lower the concentration, so you're going to have fewer particles per unit volume. So if you just imagine a 1 cubic centimetre volume, then at a lower concentration, because of the lower pressure, you're going to have fewer particles in that volume because they've got more space to move about in, and so therefore you're going to have fewer collisions with the activation energy, or greater than the activation energy, per second, and so the rate will decrease. Question about catalysts now. So it's a bit of recall. Write an equation for the industrial preparation of ethanol which uses an enzyme catalyst. And so it's obviously the glucose to ethanol and carbon dioxide. So it's the fermentation reaction. There it is there. The temperature must be around about sort of 35 to 40 degrees C. So I've gone for 37. And the condition is there mustn't be any oxygen present, or you could say anaerobic conditions. And then the final part, again, it's recall. The equation that takes place in the catalytic converter when nitrogen monoxide and carbon monoxide are converted into less harmful substances such as nitrogen and CO2. And there's the equation there. So again, that is pure recall from your notes.